This thing's on. I'm gonna do something a little bit different. Another installment of Onyx Void. And what you're seeing on the screen right now is my usual setup. Hold on. Get this a little bit bigger. It's my usual setup where I take this and I go and record my videos mobilely. Now, what's in here is a Raspberry Pi. This open. It's just a Raspberry Pi Zero with a lot of wiring. Turn it on. This setup, I don't know, it cost me about, I don't know, $30-$40. I don't remember the exact prices. I remember buying a bunch of these Raspberry Pi Zeros in hopes that I could make it into something. Maybe something advertising, something, I don't know, robots, something. But I just never got around to it. Just never got the funding for it. But you can see, I got a Raspberry Pi here. Got a 18650 here. There's a charging module down there, a USB port, and this is the Waveshare microphone. So it's more like, I don't know, today's money it'd probably be like $60, but back when I bought this it was fairly cheap. And let's see, the program should come on in a few minutes. You gotta give it a minute to warm up. It starts programs. Remember, this is a single core with 512 megabytes of RAM. Knowing that everybody's having RAM wars, it's nice to see that, you know, something with just half a gigabyte of RAM can still be useful. And that's just one more thing to add to why we shouldn't worry about all these RAM prices, and everybody's talking about it. But you see the light comes on, and that means the program is ready. And there's buttons up here from another project that I chopped up and glued into the housing here. And it's pretty much everything. All this came off, I think except for the Raspberry Pi itself, came off of Amazon. I think I got the Raspberry Pi off of eBay. I got them at bulk. I think I bought like 10 of them all at the same time. But first button up here. First button is to record. Second button is to stop recording. The third button is to shut this off. And this one does nothing as of yet. Now, I hope to get a potato camera at some point, a 2 megabyte combination with a microphone for a USB dongle type deal. But nobody seems to sell that. So I might have to make one just myself, just buy a module, USB module that has a microphone on it, and just, you know, solder something up. But you press record. I'm not recording this today, of course, but you press record, and you'll get a few blinks. They'll be a little bit longer every time it blinks, and when it stops blinking, that means it's recording. So it's recording now. Then I'll hit this to stop recording, and that'll blink twice or 3 times to let you know that it has stopped recording and saved the video. Then when you're done for a day, you've recorded what you wanted, you just press the third button and the Raspberry Pi should shut off. And that's it. And that's my recording setup. So going from this, I'm gonna go look at the code. Turn it off. Pull the SD card out. Before we look at the code, I'm gonna disassemble this. I thought it'd be interesting to talk about something that's not negative today. USB. You know, get into something maybe you might find fun. Once again, like and subscribe and leave a comment if you guys have any tech projects you're working on. It might be interesting. And yeah, it's kind of like, like I said, it's tossed together. This is something I made. I was originally trying to do this with a ESP32, and the audio libraries for the ESP32 are just all over the place. I could never get a straight answer as to how to get everything working. It seemed like it always need like a second chip in order to work. And I'm just pulling this apart to show the soldering on the back. Soldering in the back here. The GPIOs, of course, is for the controls. Get a little bit closer. You can see the soldering in the back here on the GPIOs is for the controls, all the buttons, and the light is soldered onto the GPIOs as well. Then you have the power and USB ports soldered on the power and USB pads. And that's the thing I like about the Raspberry Pi Zero. It has these pads on the back of them that lets you expand the USB. Before the CM4 module, this was kind of the stand-in for the CM4 module. And at some point, we would hope that Raspberry Pi would make this just a little bit more powerful, maybe 1 gigabyte of RAM, so we can get away with a little bit more. But as it is, it's fine, I guess. It's fine. It does what it needs to do. It's supposed to be for mobile type of applications, IoT applications. It's not supposed to run, a full desktop. Although it could, it just does it very, very slowly. And after this, I'm going to look at the code. The code's in Python. Supposedly very easy to learn. And with Raspberry Pi, it was supposed to be for, obviously learning and education for children. But lately, with the AI craze and corporations getting their hands more on the Raspberry Pis, the Raspberry Pi has become more corporate, and some people are using them, at least the B series, for full desktops and servers and whatnot, because they were sucking down less power than x86 chips. It's not so much now. It's one thing that Intel does still do, is make an x86 chip that doesn't suck down a lot of power, at least in their mobile sector. Whereas AMD is for more servers, even though they have mobiles. The mobiles do pretty great. In fact, what I'm recording on is a mobile desktop CPU, and it's working well. Alright, so I'm going to go ahead and cut this off, and we're going to look at the code in my converter. USB A to USB C. And we're going to look into the Raspberry Pi's code. The system should pop up here in a second. Here we are. So I don't need that. The code is in the home folder. Now, when I press the save button, the stop recording save button, the script takes the script that's in Python takes the recording from this folder and puts it into here. So if I open RSCP, the the recording for what I just did should be in here. And there it is. It's just there for a few seconds.
So it's recording now.
See if it caught anything.
Then
I don't think it caught
I'll hit
anything,
this to
but
stop recording.
that's how that works. Go back. But here's all the code. And let's see. This was just practice code to see if everything worked correctly. And this is for the control panel. If you guys want to copy this, like I said, it's for learning purposes. At some point, I bought a lot of, like I said, I was buying a lot of these single board computers to start a somewhat advertising business, but at the same time, it was to also teach people how to code. Like I said, the Python is easy to follow along once you read what it does, you know. But if you want to get down to the hardware bits, there are C++ libraries like WiringPy, which are kind of defunct, but there's also BCM that may be updated, a little bit more updated. But for this, I decided to not fight the wave, as I wanted to show that I can write Python. I can also write C. I may show that as some other video, but right now we're looking at Python. And you really only need 3 libraries for this. Raspberry Pi GPIO, of course, for the GPIOs. You need time for the delays, and you need OS for calling out the bash scripts. And let's see. You can look all this up, but the LED pin, the pin for the LED is here. The pin for the 2 buttons is here, and the while true loop constantly rotates in a loop after the Raspberry Pi started to wait and see if there's a button pressed. Like I said, OS system right here. You see, it'll call a bash script here, and if the shutdown button is pressed, it'll put this into the bash terminal and shut the Raspberry Pi down. See, beyond that, close this. Beyond that, you got the bash script itself that moves the file, the recorded file, to the other folder so I can then extract it later, and it dates it. And that's very important. Even though this thing doesn't have a time clock, a real time clock, it somehow figures out a way to actually give them different labels, which is the whole reason for doing this. It wasn't to get the month and date. It was really just so I can record multiple recordings and they wouldn't cancel each other out. I wouldn't have problems. And I believe this is the record button. Yeah, this is for the record button. When I press the record button, it starts flashing the LED, which you saw earlier. And there's a loop function here for the LED, and I'm using a output of onto the system bash terminal, which is using a record to record all this. Now, in newer terminals and newer Linux systems, a record is kind of defunct, and I cannot get it going on newer systems. I don't know if it's just due to what microphones are being used, or me just not knowing what are the correct what's the correct devices to call and how to call them. But I figured this one out. Is DHW semicolon 1 comma 0, If that doesn't sound complicated, then you're probably a cracked hacker. And of course, to get this all running at the beginning, let me see if I can get into it without it booting me out. Use the system D. Where is it? System D. System. And where are you? Yeah, okay, so the system D script that one, as you can see here, it starts that Python script, and that's one of the system D scripts that happen as soon as you turn the Raspberry Pi on. And I believe this one is description start Raspberry Pi G. I believe this one is to see control panel. This one's to start the while loop for the start recording button and the shutdown button. That's what this script's for. And there you have it, a recording device built with the good old, reliable, heavily documented Raspberry Pi Zero. Now, you may ask, why would I want to do this instead of using a smartphone or a dumb phone? I got some answers for you. One, I didn't want the web of AI listening devices that I have around me all the time, and you have around you most likely, hearing my words and making videos before me. I didn't want to feel like I was going in some kind of like psychosis, because many times I would say something out loud, or I would start talking about something, then you come home, you hop on your computer, or you whip out your phone and you get on YouTube, and all of a sudden there's a video about what you were just talking about. And that's always freaked me out. And I've shown somebody back, it was back in 2012 when I first shown somebody how that worked, that it did work, and it freaked them out, and he never called me ever again. And I've known it's been a thing for like decades now, for over a decade. Yes, YouTube listens to you. Yes, your computers listen to you. Everything listens to you. And no, the dumb phones are not safe. They're, if not just as bad, because you don't think a dumb phone would be doing it, but Nokia was owned by Microsoft at some point, so a certain amount of listening was programmed into the OSs, which is why the dumb phone could do all this. I just don't want to use a dumb phone either. And I have plenty of them sitting around that could do it or are capable of it. I just, like I said, I want the freedom to not have that happen where all of a sudden it's like, well, I don't even feel like making this video because somebody's already talked about it. Not only that, it's creepy that something is always listening to me. Like it is now, of course. I did want to get outside. I wanted this as mobile as possible. The Raspberry Pi Zero doesn't use a lot of power. That's why I can get away with using one 18650. And that one battery will last about, I think I got maybe 3 hours out of it, of recording. Maybe more. I haven't actually pushed it to, the full cutoff point, but you get a lot more than recording out of it than I would be willing to talk. Just put it that way. I did want something for a coding project for all the extra SPCs I had laying around, and I do have a lot of them laying around. That's just one of hundreds that, once again, I said I purchased a lot of them, caught them on sale way back when, in bulk, and yeah, I just never got around to do anything with them. It seemed like great sales at first, but then, the operating systems update, the Linux system itself is getting bloated. They get even more bloated. They want to use more RAM to do things, and all of a sudden, what used to be a simple task now requires, instead of 1 gig of RAM, it requires 4 gigs of RAM to open a browser, because they added so many features, JavaScript backends, and blah 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 blah, that wasn't needed. It was all working, but that's how things work these days. It never gets better. But like I said, all this is offline, so I don't have to worry about that. And plus, I got something to do with these old SBCs. I wanted to get some coding practice. As you've seen, it was all in Python. It wasn't exactly heavy coding practice. In fact, like I said, the Python coding is for children to learn how to code. And like I said, Raspberry Pi is very good at it. Because it has been very good at keeping, at least for the coding side of things, fairly reasonable for children to go and experiment and break things. Because that was the whole reason on why this SBC movement even started, this maker movement even started, is because you could buy a fairly cheap, at the time, SBC, and then if you break it, you dropped in the water, or you burnt out a power inductor inverter, and it just didn't work anymore, or you just burnt out the CPU because you shorted it. It was no big deal. You just go buy another one. It's not so much today. I don't know. The Raspberry Pi 5B is, depending on what model you get, if you get like the top of the line 16 gigabyte model, yeah, it's going to be $100 and something, and you're probably not going to break that. But you get like a 4 gigabyte, 2 gigabyte model, you can still get away with that. That's not going to hurt you too much. But for a child here, say like a child was like, let's say like 12, and they wanted to get into computers, $40 might break the bank for them because they don't have a job. Unless, of course, their parents were into tech, quote unquote, and they wanted their children to get into tech, or if they saw that there was potential there, and they wouldn't mind just dropping $40 for them to break some stuff a couple of times. But like I said, the verdict is out. Most people like Raspberry Pi, even though there's a lot of people in the older maker space that feel betrayed by it. But definitely wanted to get some coding practice in. And I wanted to record without being GPS tracked. When you record with a smartphone, when you record, especially if you're doing video, it's always trying to track faces, it's always asking for your GPS positions and stuff. And that just, once again, like the recording the voice, that just wears me out, man. I don't feel comfortable doing that. Yes, eventually they'll figure out who I am. It's Google and Microsoft or whatever. They'll figure it out. But, for as long as I possibly can, I would like to not have a secondary deep fake of me out there just saying stuff for no reason. If I can avoid that for as long as possible. But, there you have it. Like I said, leave in the comments. If you guys have any projects like this you want to share, maybe you're working on something, and we'll keep throwing our voices into the void that is YouTube. And I'll see you in the next one.